Hi, my name is Anshu and welcome to my channel Bottleneck. This is the Data Structures and Algorithm series. In this series, we will be implementing algorithms and data structures using Scala functional programming technique. All the code related to our development can be found in the description as a link to my GitHub repository. This video is about shortest path algorithm, and I will be dividing the shortest path algorithm into four parts. Part 1, we will be covering the understanding of what is the shortest path algorithm, what a graph would be, and what is a weighted graph. And in part 2, we will be implementing a weighted graph, which is basically required for Dijkstra's shortest path algorithm. And in part 3, we will be implementing the shortest path algorithm itself. And also in part 4, we will be covering up what is left over from the part 3. So let's begin. Now, what is graph? A graph is essentially an interrelationship of nodes or vertices connected by edges. Graphs are data structures that are used to depict connections with a couple of elements, where these elements are called nodes or vertices that are generally real-time objects, persons, or entities, and connections, where nodes are termed as edges. Also, two nodes only get connected if there is an edge between them. Now, second, weighted graph. A weighted graph are graphs where edges of the graph have a weight or cost, also where weight would reflect distance, time, money, or anything that displays the association for a couple of nodes it links. The weights are essential elements for Dijkstra's shortest path algorithm. Now, what is Dijkstra's shortest path algorithm? An algorithm that is used for finding shortest path, the shortest distance between the starting node and the target node using their weights is known as the Dijkstra's shortest path algorithm. The algorithm makes a tree of the shortest path from the starting node to the source as the source to all the other nodes of the graph based on their weights or the distance it covers. So Dijkstra's algorithm makes use of weights of the edges for finding the path that minimizes the total distance or weights among the source node and all the other nodes. The algorithm is also known as single source shortest path algorithm. So it's an iterative process where the shortest path is found for every iteration and new path is generated, and it will also eliminate in the process of any visited node which has the least weights or the distance. It is different from spanning tree as the shortest distance among the two vertices might not involve all the vertices of the graph, so it might drop a couple of them based on whichever distance it has to traverse. So it is important to note that Dijkstra's algorithm is only applicable when all weights are positive, because during the execution the weights of the edges are added to find the shortest path. It is also known fact that breadth first search could be used for calculating the shortest path as well for the unweighted graph and for weights where all weights are same. Say all the weights are 1, then it becomes logically equivalent to a BFS. Sorry. So let's see an example of Dijkstra's shortest path algorithm. So here we see we have a node starting from A, B, C, G, H. So this is the shortest path from A to H. So it is eliminating, or it has dropped C, D, E, F. So now while considering the shortest path, let's take a node by node. At first it starts with A, it calculates the distance from A to B, A to C. You see the neighbor for A is B and C. So the route, it will start with A0. So initial the source is A and there is no weight, so it is 0. Now it will go to the next node, that is B. So the weight is 4. Similarly it goes to next C, then weight is 3. So all these three paths are unique, so it is appended. Now from B the neighbors are E, G and C. Similarly for D, C the neighbor is D. So now the paths will be appended. Now while appending, it will also consider that if the node that is already visited should not be visited again unless the weights are less. So if you see A, B, C, 6, where weight is 6, is been striked off. So now the path A to C is having a weight of 3, A, B, C is having a weight of 6. So if I go back, here you see A to C is 3, and if you traverse to C via B, so A to B is 4 and B to C is 2. So now similarly A, B, C is eliminated. So now the score or the routes that we have is A to B with the minimum distance 4, A to C with minimum distance 3, A, B, E with minimum distance 5, A to G with minimum distance 5, A to D with minimum distance of 4. Now it will further in next iteration, it will go to the next node. So next node would be E, G and D, and their neighbors would be F, F, H and G respectively. So accordingly now it will append the path and eliminate the weights which are higher for the similar path or the end nodes. So here A, G, B, A, B, G, F and A, C, D, G are eliminated because F already exists. A to F with a weight of 6 and A to G with a weight of 5 already exists, so it is eliminated. So this completes the implementation of Dijkstra's algorithm. So here we see the path or the shortest path A, B, G, H with a weight of 6, which only considers 4 nodes even though we have multiple nodes available in our graph. Now the advantages of Dijkstra's algorithm: it is linear and it works with the iteration, and it is less complex. It is similar to VFS with as a directed graph and with weights. If all edges should be non-negative, if it is a negative value, then it will not give you correct results and it will miscalculate the weights. Disadvantages, so it does an obscure exploration that consumes a lot of time while processing, so it will be calculating shortest path from one node to all the other nodes, and that is a very tedious process. It goes on to iteration, multiple iterations, so that consumes a lot of resources. It is not able to handle negative value because it works on the association of values. So all the values or the weights are aggregated to calculate the least value, least score. And if there is a negative value, that will not give us the correct path. And also we need to maintain a track of each vertices that we have visited so that we can have the route that is planned accordingly. So that's all. It's for the Dijkstra's algorithm. I hope this video was helpful. If you enjoy this video, please like and subscribe, and do not forget to press on bell icon for my future updates. Thank you.